So, do you guys remember from section 6.3 when we had to solve a triangle, which meant that you had to find all the sides and all the angles? Well, we're doing that again, but in 6.3, it was a right triangle. And so now it is no longer going to be a right triangle. So remember SOHCAHTOA? You can't use it anymore. SOHCAHTOA is only possible in a right triangle. And so now we're talking about oblique triangles. And an oblique triangle is any triangle that does not have a right angle. So, for example, the one that you guys see right here, that's an oblique triangle because it does not have a right triangle. And then we have acute triangles and obtuse triangles. And so an oblique triangle is any triangle that does not have a right triangle. An acute triangle is a triangle that has all acute angles. And an obtuse triangle is a triangle that has one obtuse angle, because and the other ones have to be acute, otherwise it wouldn't form a right angle. So obtuse is greater than 90, and acute is less than 90. So, because we're dealing with an oblique triangle and none of the angles are right triangles, it's going to be one of these two cases. It's either going to be an acute triangle or an obtuse triangle. And so we're going to be giving you some information, and then you're going to have to solve the triangle, meaning finding all the sides and all the angles. And there's two cases. It's the law of sines and the law of cosines. So we only use the law of sines and the law of cosines when it's not a right triangle. If it were a right triangle, once again, you would use SOHCAHTOA. But because it's not a right triangle, it's an oblique triangle, we're going to use the law of sines and the law of cosines. But this one here, we're only going to be talking about the law of sines. And there's actually two cases in the law of sines on there. And we're going to be talking about in this video case number 1. And then case number 2 is going to be a separate video because that's going to take us some time. So in order to solve any triangle, any oblique triangle, you're always going to be given one side. So it's always going to have a side in it. So, and then they're going to give you some more information. So it's going to be one of these three. You're either going to get one side and then two angles, or you're going to be given one side and one angle and another side. You're going to be given one side and the other two sides. So when you're given that information, that's where we have, and I know you remember this from geometry, where it's going to be side, angle, side, angle, side, angle, side, angle. So that's what we're looking at here. That's also going to apply here. So for example here, notice how all of them, they're giving you at least one side. So all of them have one side. So we see the side here, the side in here, and these two sides. You only need one, and then the other information that we have there. So if I look at this triangle here, how do I know that this is angle, angle, side? So one of the things you need to know is that they're always going to be in order. You're only going to be able to skip one angle or one side, but not both. So for example, I know that this is angle, angle, side is because I have an angle, and then I am skipping the side, and then another angle, and then another side. I am not going to go the other way around where we have angle, side, angle. That doesn't work because I'm skipping an angle and a side in there. So we don't want to do that. Okay. Looking at this one here, this is angle, side, angle. Here's an angle. And then in the middle is the side, and there's another angle. So that's where we get the angle, side, angle. And this one here is an angle, side, angle. This one here is side, side, angle. And so we know that we're talking about a side, skip that angle, and another side. And then we have the angle. So this is side, side, angle. It's not the other way around where we have side and then here's an angle and then another side. You're never going to skip two in a row. It has to go this way. We skip this angle here, but it's side, side, angle. And so those are the ones. If you have a triangle that's given to you with A and B and then you and beta, then you could use the law of sines. In this case, it's going to be the ambiguous case. It's going to be used to be able to solve it. If I have angle, angle, side, or angle, side, angle, then we're going to use this case to be able to solve it. So in these two cases, if you look at it, we are actually given one side and two angles. It doesn't matter the order in which they're in, they're still going to apply this. So if you're given one side and two angles, so angle, angle, side, or angle, side, angle, you're going to use the law of sines. In this case here, you're going to be given two sides and an angle. So here is two sides and one angle. But this one is a little bit more because there is going to be another one where you're given two sides and an angle. What's something that you have to recognize with this one here is that the angle that's given is going to be one side and the angle opposite. So if you notice, this here is happening. So in this case here, in one angle opposite one of the sides, it has to be opposite of one of the sides. So this is side angle, and the angle is going to be opposite one of the sides. Okay, and so then that's when we're going to have to use the law of sines. But what is the law of sines? So the law of sines here is something, if we look at it, and sometimes we're going to go back to a right triangle. This one here is not a right triangle, so therefore it's an oblique triangle. And so we drop the altitude on here, and it's a perpendicular segment, so it's always going to form a right angle to the bottom. We consider this h for height, and it's dropped from the vertex on here. So if we solve for h in both below, so if we have here, what is the sine of angle A? The sine of angle A, I'm just going to look at this right here. I'm just going to look like in here, that triangle right there only, not looking at the other triangle. Then what are we going to have? The sine is going to be opposite, which is going to be h. Here it's a right triangle. So this one here, we could use SOHCAHTOA. So it's going to be the opposite, which is going to be h over c. And then for c, sine of c, we're going to do it on the other side. So that's going to happen right there. So that's going to happen right here. Maybe that was a little bit too dark. So let's go pink. So that's going to happen in this triangle. And so what we're going to have is going to be same thing. It's going to be a side opposite, which is going to be h over, and then this is going to be a. So if we look at this and if we solve it, because it says here solve for h on both of them, we have that h, because you put it over 1 and do the cross multiplication, because we have one fraction equal to another fraction. So I'm going to have h equals to c sine of a. And this one here is going to be h is equal to, because we do the same thing, a sine of capital C. So this is, if we notice, it's the same h. So if we have the same h, that means that this h has to equal that h. Well, if these two h's equal each other, that means that whatever they equal also have to equal each other. So that means that c sine of a has to equal a sine of c. And so if that's the case, that is true, so that we could see it much easier and remember it much easier. What we're going to do is I am going to divide this by a, and I am going to divide this by a, but then I'm also going to divide this by c, and I am going to divide this by c. Now, the c and the c are different. That's why we don't like using, this is the capital C. So that's the, and then this is the lowercase c. So I'm just going to make this much smaller so we know that that's the other c. And so what happens is that c and that c and that a are going to cancel, and I get sine of a over a equals sine of capital C over little c. And so that is a proportion. So notice what they have in common. Angle A, side A. So angle A and side. So the sine of angle A over A, and then the sine of angle C over side C. And it doesn't matter if I were to switch these around, switch these letters around. So this is B and this is A and so on. I'd still get the same thing. So the rule is that then I'm also going to have, if I were to do it, sine of B over B is going to equal to these same things. And this here is your law of sines. So it doesn't matter which one it is. If I want to know some information, I could put that in there and solve for it, and I find the law of sines. So this means that the law of sines, and I'm going to write it using gamma and beta because it's much easier to see. So the law of sines is going to be the sine of alpha over A is going to equal to the sine of beta over B is going to equal to the sine of gamma over C. So it doesn't matter which way you do it. We're going to fill it in, and I'll show you an example in just a minute. This here also applies to the law of sines. This is the law of sines, but this is a special case, and this one here is the ambiguous case, which we're going to do in a different video. So this one here is the ambiguous case, and so we'll talk about that later, but that is a law of sines. So here, if I am actually solving this, and I'm going to try to do this law of sines, here's the information that's given to us. Now you could draw any triangle. The only thing is that I ask you is that the smallest angle goes with the smallest angle here, and so on, and fill it as you're filling it in, and then labeling there, and then we're going to use the law of sines, and we have to figure out which case do we have. Do we have angle angle side angle, or side side angle? That's what we're going to look at right now. So if I look at this and I am filling this in, it doesn't matter which one you fill in on there and which one you consider to be your beta. So if this is 26, this looks like the smallest angle. So I'm going to say this is 26. And then we're given gamma is 57. So this one here is going to be my other small angle there. And then we're given that C is going to be 100. So if this one here is gamma, and this one here is beta, then I know this has to be B because they're opposite of each other. This one has to be C, this has to be alpha, and this one has to be A. So if I look at that, that's how you label your triangles. Now notice how I still have some information that's missing. I know that C is then going to be 100 yards. Oh, hope it doesn't start doing that again. 100 yards there. I could fill in this values because I already know some values there. So I already know that angle beta is going to be 26 degrees because that's given. Gamma is going to be 57 degrees, and then C is going to be 100 yards. Okay. Okay, very good. So this is the triangle that we have on there. Now we have to solve for it. So we're going to take, to solve for it, since we're given two angles, the other angle is going to be easy to solve for. All we have to do is subtract them from 180. So I know it's going to be 180 minus 26 degrees plus 57 degrees. And that's going to give us that alpha is going to be 97 degrees. So we have here 97 degrees. So now we found this one here, and now we're done with that. So how are we going to use, now we only have two more sides to actually solve for. How are we going to do that? And what we're going to do is we're going to use law of sines. So first we have to figure out what we're given. So when we look at this one here is going to be, this is the side that's given to you. Here is an angle, and then here's another angle. So if I look at this, this is going to be either way, angle, angle, side, because or if you go this way, I can't go angle, side, angle, because this one here is an angle, and then I'm skipping a side and an angle. I can't skip two things at one time. I could skip this one side. So it's angle, angle, side. You could also say it's side, angle, angle. Either way, it's going to be there. So I know that I'm going to have side, angle, angle, or angle, angle, side. It doesn't really matter there. And so I know that that one there, if I look at this, that's this case right there. And so I'm going to use the law of sines. So the way that you figure out the law of sines here is that you're going to do the sine of 57 degrees, because that is going to be your alpha. I'm sorry, your gamma, and it's going to be opposite 100, which is your C, and that's going to be, and I could use either one of them, but the one that I know is 26 degrees, and then this one here is the other unknown. So it's going to be the sine of beta, which is 26 degrees, all over B. And so notice how I use the information that's given so that I only have one unknown, and then I could actually do the calculations and solve for it. So when I solve for this, I am going to have, hold on, let me move this down. So when I solve for it, I am going to do the cross multiplication because it's one fraction equal to another fraction. They're proportional. So that's going to give me B equals to sine of 57 degrees. I'm sorry, it's not equals. Hello. Okay, so it's B times is equal to 100 sine of 26. So if we do that, B is going to equal to 100 sine of 26 all over sine of 57. And so then you put that in your calculator and then you solve it on there. So let's do that right now. So if we look at the calculator, we are going to put in, and make sure you're, because we're working with degrees, make sure your calculator is on degrees. Mine says degrees, so we're good to go. So we're going to put in 100. Well, let's do, for that, control division sign, and then we're going to do 100, and then trig sine of 26. And we're then going to go to sine of 57. And then we hit enter. And if you don't get it, make sure you could do control enter for the approximate there, and you get the answer to be approximately 52.2698. Now, we talked about storing information. This is a good time to remember how to store. So what you're going to do is you're going to do control and then vars right here, right above the 9. It says STO. We're going to do that. It's saying that we're going to store it. This is B, so I'm just going to put it in B there, and then hit enter. And so now it's stored. So now if I do B and I hit enter, it's going to give me that value. And that's going to be stored in there until I actually take it out or change it. I won't take it out. I just change it and replace it with the values. So now I know how to, all I have to do is, if I ever use B again, I could actually just use that again. Okay, so now going back to where we were, that is going to be your B. So that is going to be 52.27 yards. Okay, and now we need to solve for A, and so we do the same thing that we did before. So I would use only the information that's given to us if possible. I would definitely not use ones that I came up with on my own, because what if I made a mistake? So I would suggest you do the same thing, unless it's not possible. Sometimes it's not going to be possible, and you are going to have to use the information you found. But try to avoid it as all possible. So when you put this in there, so again, we put that in, do the cross multiplication, and then we have that value. And it turns out that A, after you calculate it, gives you 118 and 35 yards. And so we have solved our triangle by putting in that this one here is going to be 118.35 yards, which makes sense because this here is the biggest angle, so A has to be the biggest angle. So this is the biggest angle, this is the biggest side, this is the medium angle, this is the medium side. I'm sorry, the smallest angle, smallest side, medium angle, medium side. And that's how you solve a triangle with using SAA. You do the same thing for this one here. It's going to be figuring out which kind of triangle that is. And so if we actually fill that in, we know that I'm going to say that this one here is 72. This one here is 46 because it's smaller. And I am going to call that has to be beta because we already gave this one to be gamma. And then this one here is alpha. So this one has to be A, this has to be C, and this has to be B. And so we're also given that this one here is going to be 200 centimeters. So the information that's given to us is going to be gamma, which is 72 degrees, 46 degrees for alpha, and then B is 200 centimeters. So we're given two angles and a side, just like we were given two angles here and a side, but they're the different angles on there. So this one here is a little bit different because they're giving us that this one here is an angle, and then a side, and then an angle. So this one here is angle, side, angle. And so I know that I'm still, since I have angle, side, angle, it's still the law of sines that I am using, and I'm going to do the same thing that I did up there. So we know we could find beta by subtracting it from 180, adding those two angles and subtracting it from 180, and that actually gives us 62 degrees. So that's going to be 62 degrees. Those should add up to 180 now. And then to solve it, we're going to do the sine of 62 degrees over 200 equals to sine of 72 degrees all over C. And then we do again our cross multiplication, and we end up with C is equal to 200 sine of 72 degrees over sine of 62. And then that gives you for the side C, it's going to be 215.43 centimeters. And so that's 215.43 centimeters. And that is the biggest angle. And so far, it's actually fitting in there correctly. So that means that this has to be smaller than 200 and 215 since this is the smallest angle. So we do the same thing that we did before, sine of 62 over 200. But this time I'm going to do 46. So that's going to be over A. And then you do the cross multiplication on there, and you get A is equal to 200 sine of 46 all over sine of 62. And it turns out that A is going to be 162.9 centimeters. And that makes sense because this has to be the smaller side, centimeters. And there you go. Smallest angle, smallest side, medium, biggest. Very good. That is the law of sines in using case 1.